Perfection, innovation, a relentless drive to push beyond the limits of the possible. This is the legacy of Ayrton Senna. But what if you could translate that spirit into concrete, steel, and glass? What if you could build a monument, not just to a legend, but from his very philosophy? That question is being answered right now. Not in Dubai, not in New York, but here in Balneário Camboriú, Brazil's own skyscraper metropolis. This is the future site of the Senna Tower, and at a planned height of more than 550 meters, it is set to become the tallest residential building on Earth. But its record-breaking height is only half the story. The real story is the series of impossible engineering battles that must be won to make it stand. Today, we're taking a deep dive into the blueprints of a future icon. We'll explore how engineers plan to conquer a geological nightmare, tame hurricane-force winds, and build mansions with even a garage in the sky. This is the engineering of the Senna Tower. How do you build the tallest skyscraper in the Southern Hemisphere on what is, geologically speaking, a beach? This is the first and most critical challenge for the Senna Tower. The ground here is an engineer's nightmare for a project of this scale. It's an unstable mix of sand, clay, and marine deposits stretching dozens of meters deep, completely incapable of supporting the immense, concentrated weight of a 500-meter tower. Building directly on this soil like a normal building, the tower would simply sink under its own colossal mass. So the solution is, if the ground is not strong enough, you bypass it entirely. The engineering here is not about building on the ground, but through it, because the more than 700 piles that make up the foundation are driven to a depth of more than 40 meters, reaching a rocky soil that supports all this amount of load. This is the technology of barrette piles. Forget simple round stakes. These are massive rectangular columns of reinforced concrete, built deep within the earth. It begins with specialized excavators using massive clamshell grabs to dig deep trenches. To stop the sandy walls from collapsing inward, the trench is continuously filled with a heavy, viscous fluid called bentonite slurry. It acts as a temporary placeholder, exerting hydraulic pressure on the walls. The excavation continues until it hits solid granite bedrock, reaching more than 60 meters down. Only then does the next phase begin. A colossal cage of steel rebar, weighing many tons and pre-assembled on the surface, is slowly and carefully lowered into the slurry-filled trench. Finally, high-performance concrete is pumped in from the very bottom of the pile. As the concrete fills the trench, it displaces the lighter bentonite slurry, which is pumped out from the top. This ensures there are no air pockets or weak spots. What's left is a perfect monolithic column of steel and concrete locked directly into the bedrock. This process is repeated dozens of times, creating an artificial forest of subterranean pillars. This is the Senna Tower's man-made root system, a foundation that will transfer every single one of the building's hundreds of thousands of tons of weight. Not onto the sand, but directly onto the solid crust of the continent. It's an invisible giant, holding up the visible one. With the battle underground won, a new war begins hundreds of meters in the sky, the war against the wind. A 500-meter structure on the Atlantic coast is a giant sail, constantly battered by invisible forces. Here, aerodynamics isn't about aesthetics, it's about structural survival. Drawing inspiration from its namesake sport, the tower's very shape is a weapon. The curves, the setbacks, the tapering form, every element is meticulously designed in computer simulations to confuse the wind. On a simple building, wind can create a rhythmic, oscillating pressure, a dangerous phenomenon called vortex shedding, which can cause the building to sway back and forth. The Senna Tower's aerodynamic profile is designed to break these vortices apart, shedding them randomly and preventing any dangerous resonant frequency from building up. But even the most clever shape has its limits against the raw power of nature. For absolute comfort and ultimate safety, the tower hides a secret weapon in its crown. This is a tuned mass damper, or TMD, a colossal 800-ton block of steel, suspended to act as a giant pendulum. But it doesn't swing because a computer tells it to. The genius here is far more subtle. It's all about frequency. Every tall building has a natural frequency, the rhythm at which it prefers to sway. The TMD is precisely tuned through its mass and cable length so that its own natural frequency is identical to the building's. The key is what happens next. Due to inertia, when the building sways in one direction, the massive pendulum wants to stay put. This means it passively swings in the opposite direction, perfectly out of phase with the building's motion. But the real magic isn't the counter swing itself, it's how the energy is removed. The mass is connected to the building structure by enormous hydraulic dampers, essentially the world's most sophisticated shock absorbers. As the mass swings back and forth, it pushes and pulls on these pistons. This action forces fluid through small orifices inside the dampers, converting the raw kinetic energy of the building's sway into simple heat, which then harmlessly dissipates. So you have a foundation locked to the Earth's core and a design that slices through the wind. But what is the skeleton that connects them? How do you build a structure so tall and slender that it can support its own immense weight while resisting the massive leverage forces of the wind? The tower's strength comes from a composite system, blending the compressive power of concrete with the tensile strength of steel. At its heart is the spine, a massive reinforced concrete core. This colossal vertical element houses the elevator shafts and stairwells, but its main job is to act as the primary backbone of the building, resisting the majority of the vertical loads. And this isn't ordinary concrete. For the lower sections of the tower, engineers will use an ultra-high performance mix with a compressive strength of up to 100 megapascals. That's 4 to 5 times stronger than the concrete used in a standard house, capable of withstanding unimaginable pressure. But for a super slender tower like this, a spine alone is not enough. To prevent it from bending like a fishing rod in the wind, it needs shoulders. This is the job of the outrigger system. At several key mechanical floors, massive steel trusses will reach out from the central core and lock into the huge perimeter columns. This system acts like putting your arms out to stabilize yourself. It connects the super-strong spine to the outer frame, turning the entire width of the building into a single, super-stiff structure. It is this synergy between the core and the outriggers that gives the Senna Tower the rigidity to reach for the sky. What if your private garage wasn't in a dark basement, but was a centerpiece of your living room, 400 meters in the sky? Welcome to the Sky Drive. This is a system of unparalleled sophistication. The project calls for 2 dedicated car elevators to ensure speed and redundancy. Each one is designed to lift a vehicle weighing up to 3,000 kilograms, more than enough for a large armored luxury SUV. They will ascend at a swift 2 to 3 meters per second. The system delivers your vehicle into a private sky garage. It's no longer just a car, it's a piece of kinetic art, a feature of your home. The engineering required for this is staggering. Zero vibration lift mechanisms, fail-safe locking systems, and a level of automation that feels like science fiction. It is the ultimate fusion of automotive passion and architectural engineering. And this dedication to experience extends throughout the tower. A fleet of high-speed passenger elevators will use intelligent destination dispatch systems to move residents efficiently. And behind the walls lies another unseen engineering feat, the mechanical, electrical and plumbing systems, providing consistent water pressure, circulating fresh air and managing waste across 500 vertical meters is a challenge as complex as the structure itself. The architects speak of interpreting Senna's S not just as a logo, but as a representation of the flowing dynamic lines of a racetrack. The relentless focus on cutting-edge technology, from the wind tunnel-tested aerodynamics to the futuristic SkyDrive, is a direct reflection of Senna's own obsession with pushing technological innovation in Formula One. We've conquered the ground, we have tamed the wind, and we have decoded the engineering that allows this titan to touch the heavens. But once the battle of construction is over, a new story begins. The story of life inside the machine. What does it actually mean to inhabit a 500-meter-tall icon? The experience begins here, at the podium. These first floors are not just an entrance, they are a statement of intent. A monumental lobby over 15 meters high welcomes residents home. The design echoes the world of motorsport, but it's so much more than a lobby. The Senna Tower's podium is a vertical lifestyle hub. It is slated to house world-class retail spaces, signature restaurants helmed by renowned chefs, and a comprehensive wellness center. The idea is for residents to access a level of convenience and exclusivity that removes any need to leave the tower for the city's most coveted experiences. Ascending the tower's spine, we arrive at the private sanctuaries. Exclusivity is the guiding principle here. Most floors will house only 1 or 2 residences, guaranteeing 180 or even 360-degree panoramic views. There is no back-facing apartment in the Senna Tower. Every window becomes a living masterpiece, framing the sunrise over the Atlantic or the glittering cityscape by night. The engineering of comfort here is just as rigorous as the structural engineering. Double-glazed, acoustically treated glass creates a bubble of perfect silence and temperature. Soaring ceilings, far above the standard, amplify the sense of space. And of course, the private heated pool on your balcony, hundreds of meters in the air. It is your private oasis, suspended between the sky and the sea. Each residence is not an apartment, it's a sky villa. And finally, the crown. The very top of the Senna Tower is reserved for the apex of the residential experience. Here, residents will have access to a leisure complex that rivals the world's most exclusive resorts. A private observatory, an event lounge, and what will surely be the highest gymnasium in the Southern Hemisphere. This space is not just an amenity, it is the final destination of the vertical journey. It is the reward for living within a structure that defies the limits. It is the pinnacle in every sense of the word. The Senna Tower is a universe of engineering, design, and innovation. We've scratched the surface of its foundation, its structure, and its amenities, but a project of this magnitude has 1,000 more stories to tell. Do you want a deep dive into the construction logistics, showing the day-to-day challenges of raising one floor every week? Do you want a breakdown of the passenger elevator technology, the fastest and smartest on the continent? Or maybe you want a full analysis of the project's sustainability, from its water consumption to its energy efficiency. Let us know in the comments which part of the Senna Tower's engineering fascinates you the most.